Assalamu alaikum everyone. You are listening from Nasimujjaman and I'm with my two groupmates Ahmed Nur Miraj and Sumaya Afroz. So we are here to discuss about claim detection in biomedical Twitter post ACL Anthology. So let me begin with what ACL Anthology is. The ACL Anthology is a collection of peer-reviewed papers in the field of computational linguistics and natural language processing. The papers are organized into sections by topic, and each paper has its own page with links to the full text, abstracts, and other metadata. And ACL Anthology is freely available online, and papers can be downloaded in PDF or HTML format. So, biomedical topics are no exception to the large volumes of valuable and innovative material that can be found on social media platforms like Twitter. It is crucial to contextualize social media posts and determine whether a claim can be proven with a citation to a trustworthy source or just up for debate. False information can be particularly harmful to biomedical matters. This issue is addressed by automated fact-checking and fake news detection techniques. The aim is to fill this research gap and annotate a corpus of 1,200 tweets for implicit and explicit biomedical claims, the latter with span annotations for the claim phrase. Finding biomedical claims on Twitter is a task with roots in both the discipline of argument mining and the study of biomedical language. Argumentation mining can be used to extract arguments from many different text types. This covers more interactive platforms like fora and online content like Wikipedia, extract argument structures using comments from blogs and forums as examples. Argument mining is also used in professionally produced content such as news articles and legal fillings. Claims can be phrased as either a classification questions, does a document or sentence contain claim, or a sequence leveling question, which token comprise the share. The emphasis on formal writing is one element that most automatic claim detection research shares. There are still limitations to biomedical arguments mining, also to other text kinds. The topic of computational linguistics, known as biomedical natural language processing (BioNLP), is highly regarded in the biometrics community. One area of emphasis in this automatic extraction of information from life science articles, such as entity recognition of diseases, drug names, protein and gene names, and relations between those and connection between those and other entities. Social media text and web content have also been subject to biomedical text mining techniques. One area of emphasis is examination of Twitter about pharmacovigilance. Other topics include identifying personal health, mentions extracting adverse drug reactions, monitoring public health. A new research compared the content of scientific text and social media in the biomedical field. Now, the rest of the part will be discussed by my group mates. Thank you.
Assalamu alaikum everyone. My name is Ahmed Nur Miraj and let's begin. Corpus creation and analysis. As the basis for our study, we collect a novel Twitter corpus in which we annotate which tweets contain biomedical claims and which tokens correspond to that claim. Data selection and acquisition. Sample of the search terms we used can be found in the table in 2.3. Sample tweets from 4 query categories. For each of the medical topics, we sample English tweets from keywords and phrases from 4 different query categories. Number 1 is the name of the disease as well as the respective hashtag for each topic. Topical hashtags, combinations of the disease name with words and verb forms. List of medications, products, and product brand names from the pharmaceutical database named Drug Bank. Annotation. The claim element is widely considered the core component of an argument. While there are different schemes and models of argumentative structure varying in complexity as well as in their conceptualization of claims, the claim element is widely considered the core component of an argument. We define the claim as the argumentative component in which the speaker or writer expresses the central controversial conclusion of their argument. Second part includes all elements that are used either to substantiate or disprove the claim. Focus on the claim element and assign all to its a binary label that indicates whether the document contains a claim or not. Annotate explicitness or implicitness. If a tweet is labeled as containing a claim, for explicit cases the claim sequence is additionally marked on the token level. Annotation procedure. A1 labeled 1000 tweets while A2 annotated 300 instances. 100 tweets were provided to both annotators to track agreement, which remained stable. Annotating 100 tweets took approximately 3.3 hours. Overall, we observed that the agreement is generally moderate. Separating claim tweets from non-claim tweets shows an acceptable k equal to 0.56. Qualitative analysis. Subsample of 50 instances. To obtain a better understanding of the corpus, we perform a qualitative analysis on a subsample of 50 claim instances or topic. Analyze 4 claim properties. The tweet exhibits an incomplete argument structure. Different argument components blend into each other. Different argument components. The text shows anecdotal evidence and it describes claim implicitly. Methods. We describe the conceptual design of our experiments and introduce the models that we use to accomplish the claim detection task. Classification tasks. We model the task in a set of different model configurations. Binary. A trained classifier distinguishes between claim and non-claim. Multiclass is a trained classifier distinguishes between explicit, implicit, and non-claims. Multiclass pipeline. A first classifier learns to discriminate between claims and non-claims. Each tweet that is classified as claim is further separated into implicit or explicit with another binary classifier. Model architecture. NB is a Gaussian knife bias with an average vector of the token embeddings as input. LG is a logistic regression with the same features as in NB. BILSTM is a classifier which can consider contextual information and makes use of pre-trained embeddings. BERT. We use the pre-trained BERT base model 7 and fine-tune it using the claim tweet corpus. Thank you.
Assalamu alaikum everyone. This is Sumaya first. Let's begin with my first part, experiment and claim detection. With the first experiment, which was explained by my previous member, we explored how reliably we can detect claim tweets in our corpus and how well the two different claim types, explicit versus implicit claim tweets, can be distinguished. We use each model mentioned in section 4.2 and section 4.1. Result for the claim detection experiment separated into binary and multiclass evaluation. From our corpus of 1200 tweets, we use 800 strings for training and 200 as validation data, and then categorized into different models, for instance LG models, LSTM models, RT models for this experiment. Further, we oversample the binary class of implicit claim to achieve a balanced training set. To ensure comparability, we oversample in both the binary and multiclass setting. And finally, from this experiment, we observed that for the binary evaluation setting, casting the main problem as standard prediction task is not beneficial. The BART and NB performance are slightly worse, while the NSTM shows substantially lower performance. In the multi-class evaluation, the scores are overall lower. The best result is obtained in the pipeline setting. From a manual introspection of best performing model is in the binary setting. It is difficult to detect general patterns. The models struggle to detect implicit claims that are expressed using binary or a rhetorical question. Next part is cross-domain experiment and result. We see that the model show acceptable performance in a binary classification setting. In the following, we analyze if this observation holds across domains or if this information for another out-of-domain corpus can help. As the binary LG model achieved the best result during the previous experiment, we use this classifier for the cross-domain experiments. We work with paragraph of persuasive essay as a comparative corpus. We use the resulting essay model for making an in-domain as well as a cross-domain prediction and vice versa for the Twitter model. We can see that the essay model is successful for classifying claim documents in the in-domain experiment. Compared to the in-domain settings for tweets, all evaluation scores measure substantially higher. And my final part is discussion and future work. From our experiment, we showed that we can achieve an acceptable performance to detect claims when the distinction between explicit or implicit claims is not considered. In the cross-domain experiment, we see that the text formality, which is one of the main distinguished features between the two corpora, might be an important factor that influences the level of difficulty in accomplish the claim detection task. Our hypothesis in this work was that biomedical information on Twitter exhibit our hypothesis in this work was that biomedical information on Twitter exhibits a challenging setting for claim detection. Both our experiment indicates that this is true. And finally, future work needs to be investigated what might be the reason for that. We suggest future work on claim detection model optimize those to work on across domains. To enable such research, this paper contribute a novel research. This resource could be further be improved. Thank you everyone.